Hello everyone, welcome to the course on data structures and algorithm. In this video we are going to see AVL tree. The name AVL has come after its inventor Adelson, Welsky and Landis, and basically it's a self-balancing binary search tree. So these are the two conditions of AVL. The first thing is it should be a self-balanced one, and second condition is it should be a binary search tree. So binary search tree, so we know that if binary search tree is having two conditions. First one is the binary tree. Binary tree means the number of children should be either 0, 1 or 2. That is the first condition, 0, 1 or 2. And second one is the left node should be less than the vertex, and the vertex should be less than the right node. These are the two conditions for binary search tree. And the balancing thing is height of left subtree minus height of right subtree. The difference should be either -1, 0 or 1. If this is what we call it balance factor. So balance factor is the height of left subtree minus height of right subtree, and it should be -1, 0 and 1. And if this is not the case, if the balance factor is -2 or 2 or -3 or 3, in that case we need to balance out the tree, right? So if after every insertion in AVL we will be calculating the balance factor, and if the balance factor is not within this range -1, 0 and 1, then we need to balance out it such that at the end you get this balance factor equal to -1, 0 and 1. Now let's see what is this. So how to balance out the tree? So there are 4 different cases. Let's take the very first case. This is a binary tree. Alright, now we can see that over here with 0 there is no left subtree and no right subtree. So what is the balance factor? 0 is the height of left side and 0 is the height of right side. So now it is 0 minus 0, so balance factor is 0. In case of 20, the left side we don't have anything, so 0, but on right side we have one child, so it is 0 minus 1, so it is -1. And for this 10, the left side is 0, but the right side there are two children, so it is 0 minus 2, so -2. So if it is -2, then it's a problem. It has to be between -1, 0 and 1. Now because this is -2, I need to sort out. So what do I need to do? So because I am going 2 times right, I need to take a left or anti-clockwise movement. So I need to take a left or anti-clockwise movement, something like this. So for that, first I will be dragging this 10 down. I will be pushing this 20 up into the vertex thing, and then I'll be putting this 30 in place of 20. So it will be something like this. 20 will be my vertex. Now 10 will be my left node and 30 will be my right node. So you can see now this has been balanced. So now the balance factor of 20 is 1 minus 1 is equal to 0, and balance factor of left is 0 minus 0, and balance factor of right is 0 minus 0. So for all these nodes the balance factor is 0. So this is 0. Now second case is something like this, wherein I'm having 20 on left side of 30 and 10 on the left side of 20. So let's check this out. Balance factor of 10, because there is no left and right subtree for 10, the left 0 minus right 0 is 0. Now for 20, left hand side I am having one child, but on right hand side there is no child, so 1 minus 0 is equal to 1. And for 30, the left hand side I am having 2 children, but on right hand side I don't have any, so it is 2 minus 0 is equal to 2. So you can see now this 2 is a problem. This 0 is fine, the 1 is fine. The balance factor should be between 0, -1 and 1. It should be any one of these 3 values, but now this is 2. So we need to balance out the tree. How? Because now we are going 2 times left. So in this case now we'll make a right turn or clockwise turn. So this 30 will go down, the 20 will become the new root, and 10 will be replacing this 20. So now you can see, now 20 is my new root, 10 is left, and 30 is right. So this is my vertex, left and right, and we can see that 10 is having no left, no right, so 0 minus 0 is 0. Then right is having no left, no right, so 0 minus 0 is 0, and vertex is having 1 left and 1 right, so 1 minus 1 is 0. So for all these three, the balance factor is 0. So we have balanced it out. Case 3 is something like this. We are having 30 on the right hand side of 10, but 20 on the left hand side of 30. So what am I going to do is, look at this, the balance factor of 20 is 0 because I don't have anything on the left, I don't have anything on the right, so 0 minus 0 is 0. For 30 I am having one child on the right and nothing on the left, sorry, one child on the left and nothing on the right, so 1 minus 0 is 1, so this is fine. But for 10 I am having nothing on the left, 0, but I am having two children on the right, so 0 minus 2 is minus 2. So this is a problem. So this is a problem. Now how do I do that? How to balance it out? So for that, first we try to take a clockwise movement for this 20-30. So 20 will go at the place of 30 and 30 will come down. So it will be something like this. So 10, 20, 30. And now because we are doing right movement, what I need to do is I need to make left or clockwise movement, anti-clockwise movement, sorry. So in this case, this 10 will go down, this 20 will become a new vertex, and 30 will be replacing 20. So now it will be something like this, and we know that for this 10, 20 and 30 the balance factor is 0. And the last case is this one. Over here I am having 10 on the left hand side of 30 and 20 on the right hand side of 30. Now the balance factor of 20 is left is 0, right is 0, so 0 minus 0 is 0. For 10 there is nothing on the left, so it is 0, but one child on the right, so it is 1, so 0 minus 1 is minus 1. And for 30 there are two children on the left hand side but nothing on the right hand side, so 2 minus 0 is 2. So now I need to work for this 2. So how am I going to do it? So for that, first we will be making a left turn for these two nodes. So 20 will come up and 10 will go down over here. So it will be something like this. Now in this case, as we know, we are going 2 times left, so I'll be making a right move, or we call it a clockwise move. In clockwise movement, 30 will go down, 20 will come up, and 10 will be replacing 20. So this is my final outcome, and now you can see that this is my balance thing. Now let us try to construct AVL tree for some numbers. So we are given some numbers, so let us try to do one by one. So for first is 13, 16 and 10 we don't have any problem because 13 will be root, 16 will go on the right hand side and 10 will go on the left hand side, because this must be, the left side must be less than vertex and that must be less than right side. So 10 is less than 13 is less than 16. So first is this one. Alright, so this is fine. Now next is 8. So 8 should be going on the left hand side of 30 because 8 is less than 30 and it is also less than 10, so it should go on the left hand side of this. So now you can see 8 is on the left hand side, and if you check now the balance factor for this 13, there are 2 children on the left hand side and 1 on the right hand side, so 2 minus 1 is 1, so no issue at all. Now next comes 54. So 54 is greater than 30, so it should go on the right hand side. 54 is greater than 16, so it should go on the right hand side. So it should be something like this. So if I do that, you can see that 54 is on the right hand side. Now next comes 3. So 3 is less than 13 and 3 is less than 10 and 3 is less than 8. So 3 will come here. Now if you check, you will find some problem over here. Why? Because how many children are there in the left hand side? 2. How many children are there in the right hand side? 0. So 2 minus 0 is 0, and now I need to work it out. For all other it is either 0, 1, 1, minus 1, 0. So for all other it is fine, but this 2 is problem. So I need to work it out for this 2. And how do I do that? So for that, what do I need to do? So I need to make this particular thing, because now I am going, this left. So I need to make a right turn. So this 10 should go down, 8 should be my new vertex, and this 3 should be on the left hand side. So now you can see that 10 has come down. Now 8 has become my new vertex, this one, and 3 has replaced 8. 3 has replaced 8. So now this one is balanced out. Now next comes 12. Okay, so let's start doing from this. So 12 is less than 13, so it should go on the left hand side. It's more than 8, so it should go on that right hand side. 10 more than 10, so it should go over here. So 12 should go here. So let's check this out. How does it work? So it goes here. And now if you do the checking, see, now everywhere is 0, minus 1, 1, minus 1, 0, minus 1, 0. So this is perfectly okay. I don't need to do anything. Alright. Now the thing is, let us move further. Now in this case, if I go further, my next is 11. So 11 is, you can see, less than 13, so go left hand side. More than 8, so go right hand side. Greater than 10, so go right hand side. But less than 12, so go left hand side. So now 11 will come somewhere over here. Now if you see, then I have some problem. So what are the problems? The first problem is over here, minus 2, and second problem is over here, minus 2. Third problem is over here, minus 2. So if we can solve this problem, I think these two problems may automatically be solved. Now for solving this problem, we know that, now let us consider this problem, 10, 12 and 11. So now I am just drawing that 10, 12 and 11. And now you can see, first I'll be making a right turn. That means I'll be bringing 12 down, and then I'll be putting 11 over here. So now this is done. Now these three are all in the same line, and now I'll be making a left turn. So if I make a left turn, what will happen? This 10 will go down, 11 will become my new, 11 will become my new node vertex, and 12 will become the 12 will become my right node for this 11. So now you can see that automatically this problem has been resolved over here. So now let's go for adding the next number. So next number is 9. So we know that where the 9 is to be added, so it is less than 13, so it should go on the right hand side. Let's talk of 8. So it is greater than 8, so it should go on the 11 side. Now it's less than 11, so it should go on the left hand side, and again less than 10, so it should go over here. 9 should go over here. So you can see that 9 is over here. And now I have some problem over here regarding my balance factor. So now I need to work out this particular thing first. So if this is resolved, this will automatically be resolved. Okay, so now I am talking of this 8, 11 and 10. So first, because it is on the right hand side, sorry, because it is on the left hand side, I need to make a right turn first, clockwise turn first. So now I'll be making this one first, and then you can see that this median element 10 has come on the vertex, the leftmost is less than and the rightmost. And now if I put all the three back to the place, alright, so it will be something like this. So this 10, 8 and 11, 10, 8 and 11 are placed. Now what are the other numbers? 3. 3 goes on the left hand side of 8. The other number is 9. 9 goes on the right side of 8, and 12. 12 goes on the right side of 11. And now you can see all the balance factors have been sorted out. Now next is 59. So we know that 59 is greater than 13, greater than 16, greater than 54. So 59 comes here. But the moment I put 59, you can see there is a problem regarding balance factor over here. The 16 does not have anything on the left side, but it does have 2 on the right hand side. So now, because these all are right problem, so what I'll do, I'll make a left move, and 16 I'll bring it down. Okay, so I'll be putting 16 here, 54 here, and this 59 over here. So this is what I wish to do. So look at this. So this is done, 54, 16 and 59, and all the balance factors have been adjusted. Now next comes 20. So 20 is greater than 13, so it should go here. 20 is less than 54, so it should go here, but 20 is greater than 16, so 20 should come here. So let's check this out. So 20 has been put over here. Now with this there is no problem at all these balance factors are okay. 0 0 0 minus 1 1 0 0, all this 0 0, so no problem at all. So next comes 15. So for 15 we can see that 15 is greater than 13, so it should go on this side. 15 is less than 54, so left hand side. 15 is less than 16, so on the left side. So again, after inserting 15 there is no problem. And last one is 21. So far as 21 is concerned, it's greater than 31, so I should go right. Less than 54, I should go left. Greater than 16, I should go right. Greater than 20, I should go right. So 21 should be over here. So now you can see 21 is over here. But the moment 21 is put over here, I have some problem here at 54. So now what I'll be doing, I'll be working on this particular part, 54, 16 and 20. And I know which is the median. 20 is my median. So 54 should go on the right hand side, and this 16 should go on the left hand side. So if I do this, so this is my outcome. And now if I put them all together, you can see now I have 20 as a vertex, 16 on left hand side and 54 on right hand side. Okay, and what are the other numbers? I need to set this 15, which is less than 16, so it is set here. Now the 21, which is greater than this 20 but less than 54, so it is set here. And last is 59, which is greater than 54, so it is set on the right hand side. So all the numbers have been set, and now you can see that all the balance factors are either 0, -1 or 1. So this is my AVL tree. So thank you very much all of you guys. In our next video we will be talking of B trees.